Alrighty, good morning and welcome to our webinar, Successful Adoption of Model-Based Testing in Agile QA. My name is Sarah Lynn Bruner and I will be your host for today. And today's presenters are Anna Royzman and Dharminder Dewan. A quick background on both. Anna is the founder of Global Quality Leadership Institute, a nonprofit organization whose goal is to becoming the leading advocate for quality and technology through innovative educational programs. Testmasters Academy is an initiative that is envisioned and managed by Anna directly. Anna is a renowned international speaker and the recognized expert in software test leadership. She held various test management roles for 14+ years, served as the executive at-large on Association for Software Testing's board of directors as president of AST Quality Leader, and as a software test professionals community advisory board member. Anna is also the co-founder of NOIC's Testers and the founder of TMA's Leadership Series Meetup. Welcome, Anna.
Thank you.
And Dharminder. Dharminder is an Agile QA manager at InfoStretch. Dharminder carries more than 20 years of IT experience in architecture and design in QA, QE, and automation areas, coupled with product and project management experience for various companies. While working at different technical management positions with companies like TCS, Fujitsu, OpenText, Dharminder has led and guided the transition from waterfall to agile methodologies, ensuring faster time to deliver and deploy in various fast-moving environments. He has an extensive experience in DevOps and shifting quality left in waterfall models, leading to a hybrid and fully agile model. Welcome, Dharminder.
Welcome to the webinar, everyone. Today we're going to talk about model-based testing. Our agenda for today, I'm going to do my part of the presentation, then I'm going to turn the mic to Dharminder, and he's going to talk about some test use cases that they implemented with InfoStretch and some practical advices that came up from their experience. I'm going to talk more about kind of big picture, what is model-based testing, what are the pros and cons of model-based testing, and what to watch out for, what's the implementation approach, etc. I'm going to also discuss some successes and failures, I would say, in implementing this approach. So with that, we're going to start. I'm going to take control, and we're going to go for it. Okay. Okay. So in a nutshell, model-based testing is the implementation of a code that models the behavior of the system under test, replicates the behavior, and then it's run against the system under test. Some actions are being run, and then validations happen, comparing the state of the model and the state of the system under test. That's in a nutshell what model-based testing is. In order to, let's say, make it successful, there are several attributes that you need to consider when you deciding on model-based testing approach. One major thing about model-based testing is obviously an automated testing, and it's obviously a code. As with any code, we testers know that we need to test it. So some validation tests against the code itself needs to be implemented as well. Do not blindly trust anything that machine runs. You probably know this already. I'm going to reiterate it because it's really important for testers to understand that anything you use, you cannot trust. You need to validate. So when you consider a model-based testing approach, implement some unit tests for sure, because that's really important. You want to trust your model to perform the testing for you. Number two, model has to replicate the behavior of the system, meaning that it's version specific. If your model and your system under test are not in sync, then you're going to have some false positive or false negatives. So watch out for that when you have major changes in your validations, in your features from version to version. You definitely need to keep your model up to date. Because if you're not, then this tool is not useful for you. In order to implement the model well and do not worry about whether it's wrong or right, you have to have an established system under test, meaning if some, especially in Agile, some of the features that being implemented are supposed to get some customer feedback, meaning they could change. I would advise against implementing model against something like that if you know that something is going to change, because then you need to adjust your model to certain behavior that may or may not be there tomorrow. So ideally, the model works much better on something which is called regression, on established functionality, when you need to do a lot of regression testing. As with any tool that testers use, it has to be ready for you when you need it, meaning that if you have a release, then this model has to be ready for you. Sometimes the automation team may not be the team that directly reports into your manager, into test manager. Sometimes the automation team is outsourced. Sometimes they have their own, I would say, priorities. It's really important for a tester and the test manager, test lead, who are the customer of this model-based test automation, to be ready with that tool when they need it. And I reiterate it over and over again, if your tool is not ready for you, then you don't have a tool. Don't say that you have it because it doesn't work for you. So all those things that I said, you have to trust it. It has to be version specific. It has to work against your version. It has to work against the version that you know going to be implemented. And it's going to be there to stay. And it has to be ready for you when you need it. Because with model-based testing, there is a lot of code involved, and you really need to know that you can trust this tool exactly when you need it. With that, we're going to go into some examples. Where model-based tests may or may not work. I'm going to talk about some of the experiences that I had, and I tried it in different environments, different case studies, and just to give you a little bit of background, my company, I work for the financial company, and we started in 2001, and we implemented the version of our system, which was extremely complex. We only tested manually. We didn't have enough testers, never do. And what we implemented before we did the model was we kind of did some group tests for the whole company. The whole company was about 70 people. And we kind of had like a lot of eyes and hands on the system in order to kind of find the bugs. Well, in 2003, we went through several versions of the system. It became more established. We had many customers by that time, and the robustness and the trustworthiness of the system become really important for us as a company. Because when you have a very new product, it kind of doesn't matter. Okay, so it's kind of not working, but it's a new product, and you just adapting, and it's okay. When you like 2 or 3 years in a row, then your reputation of your company relies on the trustworthiness of your system. If something worked yesterday, it should be working today. This is what customers look for. And we realized then in 2003 that our system becomes so complex that explaining it to even testers it's not was next to impossible, but there was gazillion of different scenarios, and you need to know like intricacies of the system in order to understand what exactly you're testing. So just to give you an overview, we had two on the front end. It was an interactive system, so we have two screens. Two clients were engaged in some negotiation scenarios, trading, and each of those screens had about 30 controls. So as a tester, you kind of need to understand all the intricacies of behavior of every button that changes the state from action to action, and you need to understand it on two screens simultaneously, on two different machines. It really was a very complex system. So it wasn't development initiative, it wasn't even a QA initiative. It came from development. They wanted to invest some money and time to implement the model-based testing in order for us to kind of hit all those different scenarios, those gazillions of iterations of scenarios, and have it under our control. Because for developers, this model is as useful, the test results are as useful as for testers. We were one team. And we invested in it heavily. So for the half a year, we didn't develop any new feature. There was nothing on, not open source. It was 2003. So we developed this model-based testing internally. As I said, half a year, all the development involved, all the testers involved. We became the product owners of that project. Basically, we wrote the spec because we know how the system behaves. So we kind of combined both front-end and back-end in order to give our developers the specs on how to implement the model. Because you need to understand how both front-end and back-end works in order to provide information to the development to create that model. And this is what we did. So I will call it a successful case because exactly when we implemented 2003. It was extremely useful for us because, number one, we could give out the creation of test cases to anybody in the company, literally. Because all the logic happened inside the model, all the validation happened inside the model, we could just give anyone in a company a set of steps and say, just create the script for us, and we just run it. And this is how we, there was kind of, as I said, it was a joint initiative of the whole company. We all invested in it. And that was also for the company to understand how their system works. It was really a great thing for the company at this time, but as I said, company was 70 people. So we employed the help of everyone. We created a lot of different scenarios, and we had great coverage on basically very complex trading system behaviors. Another thing what I can do with this model, as you understand, so it's basically a set of functions, and you do you doing the data feed into the set of scenarios, and then you can generate different scenarios based on your data. What else you can do is to do combinatorial testing, meaning that you can mix and match different data sets. For example, you can mix and match different parameters. If you know how to do combinatorial testing, you can create, due to some algorithms, using some algorithms, you can create limited set of tests to cover majority of your scenarios. And Dharminder is going to talk more about that later. So some of the things that I did is to use that model with the data sets that I needed to test specific scenarios for the specific releases. Because there was some, for example, there was some work on specific feature. And when there is some work on specific feature, obviously the regression testing is needed because there is more risk introduced to the code that has been changed. We really need to validate more deeply how the system didn't mess up, didn't break because of some changes being made. So on those occasions, I would generate specific deep dive tests with really large coverage of this area just for this release. I would throw away those tests later because you don't need it. You don't need to keep them. But generation of the tests and running them was extremely easy, and you can use the model-based testing just for that. And in this respect, I would say model-based testing was one of the best approaches that we use when you really need to use a specific release and to test something very deeply. Regression test, not something new. Unsuccessful case. Coincidentally, anything that you work with depends on the context. So one of the unsuccessful, I would say, approaches with this model was the intricacies of very little, I would say, granular changes of functionality, state of the system that all needed to be implemented in a model, which create, I would say, very complex code inside the model. So we try to implement, so basically you need to put the code into all the validations of the system. And in our case, it was, as I mentioned, 30 controls, right? There were some buttons, enable, disable, there were some displays, there was some text, there was some chat messages. And with chat messages and the text, that's where the complexity becomes so enormous that we spent a month on it and we stopped. Basically, we decided we're not going to validate that because there is too many bugs that they introduced by development. It's easy to do by looking at over exploratory testing will suffice. So sometimes the model, when you make it too much of validation of some, I would say, features that do not really matter that much. For example, something like chat, it's not really a big deal. It's a chat. So if there are some bugs, then you're probably going to find it, throughout your exploratory testing anyway. So that was something that we stopped doing. Another successful case was we had one large system, we were one large company, and at some point we broke down into product units. So the company basically reorganized into product units. And all this system became several different products for several different teams. And each of these teams had their own plan of development, their own product owner. And at this point, having one model for the whole system was not really feasible anymore. So at some point, development in each of those units decided to do the direct validation test. They used kind of the model, but they didn't use the automatic assert. They put the direct validation, and this is how the model kind of ceased to exist, because we broke down into different product units. There was less coordination between different units, and each team decided that they want to have their own pace, develop their own system, and that's how one huge model was no longer supported. And then we split into different kind of mini models or direct verified tests that each product team decided to implement. They tried the different tools. So you can really you cannot tell Agile team to use something if they want to use something else, and it's easy for them. So that was one of kind of drawbacks of having something huge and unmaintainable when you have very much Agile team that go with their own pace. And with that, what I wanted to say is, as with any project, with any development, you need to adapt to the process change. If something works for your team, use it. If something doesn't work for your team, well, find something that works. So if something becomes hard to maintain, hard to communicate, hard to develop, change it. So as I said, in my specific case, when we had one model developed for the whole system and the Agile team decided to go on their own process, then this model was no longer applicable, so they switched. The last thing I wanted to say is consider short-term and long-term strategies. When you implement the model, you have to understand that it's an investment, right? Anything that is automation, development of automation, suite automation tools is really an investment. So you need to understand how you're going to use this model in a short term and in a long term. Do consider your strategies. Do consider where your model is going to be used. As I mentioned, I would suggest that it's much better used in the testing of the existing features of the regression testing. Also, as I said, it's really useful when you need to generate very deep coverage for certain feature. Throw away those tests. It's fine to throw away the test, but at some point you need to generate more. You want to test more deeply, throw it away, then with next version. So consider that. Consider where the model can be used. If your, I would say, if your product is going to be severely changed, then maybe model is not for you. But if it's stable, if it works, if you just want to build on it, and the existing features should work with the new releases, then it's one of the methodologies that could be working for you. And with that, I'm going to give the control to Dharminder and give the presentation to him. You can ask me questions later.
Thank you, Anna. That was, I think, a great start. So let's transition into how the model-based testing is working in the Agile projects. Just talking about different phases in sprint, how it is done, and what happens in the beginning, what happens at the prior to the sprint. And in Agile, in general, as you know, that we work in sprints. And when we talk about MBT, the most important here is that in the previous sprint, which is before the current sprint starts, at the end of the current sprint that we're working on, before the next sprint, there's some grooming that happens. During the grooming, the prod, dev, and QE, they would understand the stories, and based on understanding the stories and the requirements and even discussing with the BAs, they come up with the models based on the acceptance criteria. And those are the models which were for the system under test, as Anna was talking earlier. And the next part would really be that there's a quick review of the models that happens. Then there are test sequences which are generated. For all the models which are generated, there are different type of testing sequences which are generated. And that also helps development to identify the use cases and the complexity from the models, which even they need to validate as part of their unit test cases. Because the idea of the model really is to make sure that it is representative of the system under test. It should not be the case that because the test scenarios that we create, they absolutely 100% depend on the validity and authenticity of the model which is generated for the SUT. So it's very critical that it is validated. So that's what happens as part of the planning before the current sprint starts. When the current sprint starts, like any test case execution that needs to happen, because since this is automation here, we need to make sure that the test data requirement is gathered and it's given to the respective team who's supposed to give you the test data, because there are some service virtualization which happen in some companies where you need to put in the request to somebody to give you the data and then utilize those in your test cases for execution. So that's what happened as part of the sprint starting, and then you validate all that data and you start executing your the test cases. And you're also, as dev is writing their unit test cases, the automation is writing or generating the test cases from a tool. Because it's on all one of the the advantages of MBT really is that once you have the model, you can run, there are a few tools out there using the model, they're able to automatically generate the test cases. And during the sprint execution, When the dev completes the unit testing and says, okay, now QE is ready to run the test cases, which is the quality engineering team, QE would run their test cases and certify the stories based on whatever the scenarios which have been generated using the model which was generated prior to the current sprint, which was understanding the stories and all that stuff. And then once we are done with the execution, then we follow the same process again for the following sprint, which is we do the sprint, the story grooming, the pre-planning, preparation for the next sprint. All of this, there's not much difference in how MBT is implemented in the Agile process. If somebody understands the Agile process, it's all about when you start the pre-planning, when you do the actual understanding, and when you do the coding, and when you do the execution. It's very similar. It's always that whenever the current sprint is, that's where you start executing whatever stories are developed, and there is unit testing which precedes the execution of the automation test cases. So it's pretty standard from the Agile process. Now, let's look at the different type of tools what the industry offers to facilitate the model-based testing. And the example that I'm showing on the right-hand side, that's the example which is created using an open source model-based testing tool by the name of GraphWalker. And the idea of the GraphWalker is that you would, whatever system you are testing, you put in the information, and based on the information you are providing to it, it would be generating graphs. And the graph is in the form of action and verification. There are arrows which are generated. Arrows basically represent actions, and nodes represent a verification. So if I just go over the graph which we are talking about here, there's the first node, which is the start node. When you start, you just validate that if the client can be running or client can be not running. Now, if let's say the client is not running, then you would be given an opportunity to when you start the client, then it would give you the login prompt. Now, if you get the login prompt, then there's an opportunity either your credentials are valid or they are not valid. If they are valid, then you go down to the browse, which is again the verification. So in all these steps, what you would do is the understanding of this graph is that there would be an action performed. When you say we client not running, there would be a verification saying that there's an error that pops up. When you get the login prompted, then there's a verification. That means that you would be validating that a login button comes up with whatever screen you're expecting, the username, password, with the OK cancel button and all of that. So those verifications happen. So that's the idea of a model, which is a generic understanding, because once these models are created, there are tools who would walk through these models to create test cases based on different paths which are given as part of this particular model. Because what this does is, and if you look at how the system under test is represented, one of the advantages of model-based testing is that if a QA, if a BA or dev or anybody wants to pretty much understand how my system should be working, if all my acceptance criteria are validated or not, if I would be doing 100% test coverage or not, because that's one of the advantages which the model-based testing offers, that you're able to have 100% coverage by ensuring your model is very well represented of the SUT. And just looking at a pictorial representation, anybody would be able to figure out that, well, if the coverage is enough or not from the testing perspective, based on different paths we're taking. And as we know, it's majority of the time, the way the human brain works is that we are able to interpret images faster and understand them easier compared to the text. A lot of times we get lost in the text. That's where these pictorial representations are always better. And that was one of the advantages of the model-based testing that we have seen. Now, in terms of what does the MBT tools offer? Now, again, like I was saying before, one of the biggest advantage of the MBT tool is the auto generation of test sequences from the model. Again, these are not the end-to-end test scenarios that we have in the traditional QA approach. It only crawls the paths which have been defined and as described in the model. And this is a huge advantage, because one of the biggest challenges for the shift left or going into the Agile, when we are talking about 2-week releases or 3-week releases or 4-week releases, making sure the quality does not get impacted. We are doing sufficient testing. And the solution to that really is automation. There is no way within a span of a 2 or a 3 week sprint where development itself consumes almost 50% of the time, the remaining 50% is sufficient for us to do the QA or QE or all the validation without any automation. So that's a huge advantage. In Agile, we have to absolutely do automation to reduce cycles and move on to the shift left, because as all of us are aware that earlier we were able to fix the problems, better off we are. Because the advantage would be that it's more expensive to fix the problems later on. Again, that's pretty standard stuff. The other thing with MBT does is that it would provide algorithms for crawling the paths in the model. Again, these would be the random path, edge coverage, vertex coverage, and the shortest path. Because as we saw in the model just now, which I showed in the graph, there are multiple areas. So you can go pretty much that, well, I would have a successful login, then I would go to because this was a very small system that I showed. In the next couple of slides, I would be giving a little more complex system with multiple paths. That's when you'll be able to realize the value that you can, when the algorithms are generated, it can pretty much pick up any path that from point 1 to point B. It can be a successful path. It can be a failure path. Each one of them leads to a verification at the end and in between on every node, because we really want to make sure that end to end it's successful and things pass. And that's the only way, like Anna was mentioning earlier, the validity of the model, the path is very critical to ensure the test cases generated are correct. And of course, we can absolutely generate almost 100% coverage, test coverage using MBT tools, because the idea is that, again, it is automated. Even the generation of test scenarios are automated. And the duplicacy, of course, I would also mention here, the redundancy and duplicacy is not the case here, because as you would, since it would be following a path, all these tools make sure that they don't traverse the same start and end node across the same path again. So that's the validation mutually exclusive process that is followed. So we, of course, attain 100% test coverage based on the model. Again, this is a statement which I would say depends on the model which is generated. If there are scenarios which are missed in the model, then of course it would be, the test coverage would be missed. And the paths can be controlled with logical guards and actions, which basically defines that the more logical guards and the more actions you define as part of the model, that's what would be creating multiple paths from the test case perspective. If for like just now we showed, there's a valid login and there's an invalid login, those become two paths. If there's any other opportunities or options there, then that would become a third or alternative path. So more path you define, better off the model-based testing tools are in generating test scenarios. And the last one, of course, is providing weight mechanism for path edge selection in case of random. Because what really happens here is that when you define a weight to a particular path, and I'm saying that, well, this is of a higher priority to me, what would happen is when the path is generated, it would effectively say, well, these are the high priority test cases. And if I really want to give it a norm that, well, only execute P1s, then the weight is taken into consideration for executing. Because sometimes I want to get the feedback in 1 hour, and my test cases are so extensive, there's no way I can execute it in 1 hour, all the set of my test cases or my entire test suite. That's when I would be picking up the priority of the weight, making sure this is have more weightage in this particular scenario, whatever the feature of the test is. Let me move into some examples where we talk about how the models are generated, and then going into the code, actually how the code is representative of the models and how effective it is. So in this scenario, what you see is a search product. Of course, this would be applicable to any one of the sites out there, Macy's, JCPenney, any Amazon.com, anywhere where you'd be doing the searches and you would be landing on a shopping page and all that stuff. So if you look at this model, so this is a model that is generated for an online search, and we are searching a product. Now, this currently, it has two pieces. One is the initial one, where when you do a start, you launch the application, you will land onto the home page. In this case, the start piece would be, I would be putting the URL on in my browser, and my landing page would be the home page. So that's the first verification that we would be doing. Now, when we go to the home page, there are multiple actions that we can perform. I can open the shopping bag, even though there's nothing there right now, but eventually we will see that since it goes in a loop, that's the other thing which would still be, which would be valid after that. Or I can expand the menu item when I hover over the main menu item. Or I can search for an item and get the search results. Again, the principles are exactly the same, that whatever you see in the arrow is an action, and whatever you see in the blocks or a box, that's the verification or the landing page in case of a website. So from a home page, either you can go to a shopping bag page, you can go to a search results, or a menu item expanded, which would be based on if you hover over the main menu. If you search for an item, then you get to the search results page. From search results page, again, there are multiple options which can happen. Either you can open the shopping bag, you can open the product, which will be clicking on one of the items in the search results. That would take you to the product details page. If you apply the filter on the search results, then it would give you the results with the applied filters. For example, I said, okay, you know what, give me all the phone covers, and then I say, okay, only display me the iPhone 7 covers or iPhone 8 covers or iPhone X covers. So that's an example of how the results will be applied with filters. And here again, this is the model which I'm generating. When I would run this model through my test case generation tools, what this would do is this would generate my test cases for each of the paths which are being mentioned here. One path can be home page to the shopping bag page. The other one can be home page, shopping bag page, results with applied filters, going to the product details page, and going to the all submenu item products. So these are different paths which would be converting into test cases. And of course, there would be a different data set we would be talking about that would be associated with these test cases. Now, this was the searching. Now, let me go to the different aspect of this, which was, if I just quickly go back, you see on the top, the product details page. So the product details page, this is where we are. That what I did was went to a home page. Let's say I did the search results, clicked on one of the product details page, and when I got to the product details page, now I have multiple choices. What I do is either I can again hover over the main menu item, that's menu item expanded. So this, as you see, the menu item expanded is there on multiple pages. So we need to validate that functionality again. If we miss this part as part of the product details page, then this would not be tested. So that's why the importance of the validity of the model, and even Anna was saying before, compared to the current system under test, is very, very important, because that's what ensures that whatever you are testing is correct. Otherwise, your test cases would be generated for that system, which is either they would be missing functionality or they would be testing invalid functionality. So missing functionality would be test case gaps, testing gaps. And if it's invalid functionality, what that leads to is invalid failures or incorrect failures, which leads to analysis time. So pretty much sooner we are able to align the models with system test, the better off we are. With the system under test, the better off we are, because that ensures that we do not waste unneeded time. So once we talk about, we just talked about the models. So next step really from this is that what is next? So what happens is that using these models, these scenarios are automatically generated. And all these scenarios, like I said before, since they're following unique paths, they would be unique test scenarios. And the validation and correctness of test coverage and the test scenarios happens also at that level, because we just want to make sure that whatever we are covering using the model is correct and we are able to execute and they are functioning well. Again, I think this is something which we have been repeatedly saying, that test coverage, 100% test coverage follows the graph. If the graph follows the requirements correctly, we can absolutely achieve that. And of course, when we talk about this MBT, the identification and defining of test case priority and complexity, that also comes at the stage where once we have generated the test cases, what we would do is we would give all these test cases priorities as P1s, P2s, P3s, and all of us know that a lot of times we are in a case we don't have enough time for doing the execution. that's when this priority and the weightage comes into place, and both of them make a very, very intelligent system where we're able to execute our test cases depending on the time on hand. And the automation execution, of course, what that does is that makes it pretty intelligent from the execution perspective, that we pick and choose that. Let's say I say that I only want to execute P1s, only those will be executed. If I even want to say that there's a particular set of data only which I want to execute, or which I would be showing in the next couple of slides. So then you'll be able to perceive that what we really mean by intelligent, where you can pick and choose that, okay, this set of data, or let's say I'm just validating that I have a bunch of websites for which I'm working on from my current product itself. There are a bunch of URLs. I only want to validate 2 URLs out of those 10 or 20 or 30. Then it would only pick up the test cases for those 2 or 3 URLs and execute them. And then, of course, this provides us the capability that when at this step, the test models which are generated, we need to make sure that they validate against the requirements. So we do that way early using MBT. Because in Agile, it's very, very important that your tests are following along with when the development is going on. In the waterfall model, the tests, you start working on the test cases once the development is done. In this case, that's not the case, because we're talking about 2-week sprints. We have to validate within those 2 weeks. And as we know that majority of the chunk of the time in a sprint is generally consumed by the dev teams. So testing has to be in parallel with them, in touch with them as the product is being developed, just to make sure that things are on the right track. So this is the combinatorial data generation, which, and I was talking about earlier, the ideal, if you understand, if you see this data, in this data, what we're talking about a model, we're talking about parameters, we're talking about the data values on the left table, and we're talking about the URLs, the sign-ins, and a bunch of other information pertaining to that URL. So what would happen is, for the dashboard model, for the data value JCPenney, these are the bunch of other additional values I have. So if I, for this model dashboard, if I just technically say, okay, run the P1 for for where the value is jcpenny.com, it's going to come to the table on the right, and it's going to execute all these test cases which are mentioned here. So that's the one we talk about, that using data, I can extrapolate for same set of test case, I can execute it in multiple scenarios. Following up on how that gets converted into the actual scenario, step definition, and test data, this is how would be technically the end-to-end. But currently what we were seeing is the model. Now, if we come here, the scenarios which are created on the left, they are generated using one of the tools which go through the model, and they would generate a given when then, where I open the browser, I navigate to jcpenny.com, I should see the JCPenney homepage. I hover over the main menu, then the main menu item should be expanded. So this is the scenario that got created using the model. Now, as you see, if I go to the right side, what I'm doing is, these are different, the whens and the thens. Now I get into the step definition, whereas each step which is defined here, I would be defining this step. And by the way, what we are doing here is we're using Combinatorial automation framework. You guys can Google it on the internet. You'll be able to find a lot more on that. But that's from the generic concept. This is what happens. Scenario, then we do the step definition where the scenarios are exploded, and step definitions are executed using this test data. As you saw before, we were talking about a scenario 9, the example which I gave. So these are the scenarios which we are talking about from the data perspective. So it would go to this particular scenario, pull out the test data as described in the metadata piece. The data is described here. It will pick up that particular data and do the execution. And I can change that at runtime whenever I'm doing the execution, just to make sure, the execution time, just to make sure that I pick up different data, I pick it up based on the priorities. The last thing I really want to talk about is the omni-channel testing. As all of us know that one of the key things nowadays is that we are talking about multiple devices, where I would be able to create an account on one, let's say, desktop, but when I validate my or check my balances, I do that on my mobile phone. So MBT is very good even for omni-channel testing. We have tried that on the US largest US retailers, and what we have seen is the sprint velocity and closure increased by 25%. There are thousands of acceptance criteria. We are able to even reduce them and make them more understandable by converting into MBTs. And of course, the CI/CD process, we have done that for end-to-end because again, that supports the Agile. The new feature ready to market in about 4 weeks, that's been implemented using this. And the test authoring speed is reduced immensely, down by 75%, because when we author the test case, the biggest thing is that there is no basis. There's a lot of time every engineer would be spending in understanding the system under test and then implementing. What the model does is there's an initial time that we spend in creating the models to represent the SUT, and then creating test cases is pretty fast. And of course, this helps us introduce in sprint automation, which is majority of the time is a challenge, because what generally I've seen in the standard companies and standard processes, the automation generally follows one sprint behind. So the more faster we're able to automate, if we automate the automation, that makes it easier. So with that, I'll pass it on to you, Sarah. Thank you so much.
All right, Anna, looks like a question for you. Is the MBT approach suitable for any types of projects?
Not really. I would suggest to use MBT when your product is established and you have something that is kind of stable for. When I say stable, I mean features are stable. If you have a R&D project, you just discovering what would user want, right? You need frequent feedback from the user. You need to do A/B testing. I would suggest that when you have R&D, do not use something heavy as model-based testing. I would even suggest do not use any automation when you have something like R&D. You know that you need frequent feedback from the user. Your features may change. Your workflows may change. Automation is not suitable for that. For kind of something that is already in production, something which is already customer reliance on, use something like that. That's like much better choice for established product, established features. And something like regression-based. I would look for regression-based kind of focus when you use model-based automation. Because model is complex in itself. You don't want to add this complexity to change something today, change something tomorrow, change a workflow again. Then you're going to be running after the changing features, and I don't think it's worth it. So I would say more established system we have, the better this fits.
Great. Thanks so much, Anna. And Dharminder, what are some of the disadvantages of model-based testing?
So in my experience, some of the disadvantages that I've seen with the model-based testing is pretty much we need to make sure that the testers or QA engineers have some essential abilities which help them to understand the system and convert them into a good model. Because if the ability is missing, then we'll be coming up with a model which is lacking and in the representation of the entire system. That's one. And of course, sometimes if the ability is not there, it's a little complex, like Anna was also saying, to perceive the prototype or the model itself. And there's a lot of iterations you sometimes go through if you're not able to really do a good job in understanding the system end-to-end. Even though MBT does not really support end-to-end or does not ultimately lead to end-to-end testing, it does the different flows that are defined as part of the model. It's very important that we understand the system end-to-end so that we can look at all the permutation combinations, all the steps that would be, all the flows that would be going through from the validation of the system before we start working on the prototype. And of course, that pretty much leads to another thing, which is the knowledge curve, the knowing curve, the understanding curve. That is a little higher in the initial stages, but once it is done, then we can all, the advantage we of course get is the time in which we are able to automate, the time saving which is there. So it gives back in the later stage. But initially, those are the challenges.
Great. Thanks so much, Dharminder. Actually, another question for you as well. Is MBT widely used?
So that's a pretty interesting question. And as I see so far, I'm seeing MBT more somehow being used in the European sector. And in North America, it's being used, but not as widely. So there's a distinction there. So that's the short answer to that question. And why even I sometimes struggle with what's really happening. Is it because the visualization of the model is there a little more based on the systems which are being developed, or is it because of the fast-paced environment, the stability is not there in the future where people start working on, because like Anna was saying earlier, unless the system stabilizes, using the model-based testing is not a good idea. So when the systems are stabilizing, sometimes teams pick up different avenues of doing testing, and then probably they're not switch to MBT. That might be a reason. But interestingly, that's what I've seen, that in Europe, it's very widely used, whereas in North America, it's still catching speed.
Thank you, Dharminder. And I believe we have time for one more question. Anna, question for you. Do testers need any special skills for using model-based testing?
For using, I would say reading the scripts should be enough. It's not that you need to know what's underneath. It's good that you understand, because you're going to be working with the code, more or less. If you saw what Dharminder showed you, some of those scripts, they're scripts, right? So you need to understand kind of how to read them. It's easy to work with it when it's implemented, but you need to be, I would not say that you have to be a developer, no, but be comfortable with scripting. I would say that.
Great. Thanks so much, Anna. And I believe that's all the questions we're able to answer at this time. Also, for everyone listening, be sure to check out and subscribe to DTV. It's a new digital transformation channel that brings in industry experts. And many thanks to our speakers, and thank you everyone for joining us today. You'll receive an email in the next 24 hours with the slide presentation and link to the webcast replay. And if you have any questions, please contact us at info@infostretch.com or call 1-408-727-1100 to speak with a representative. Thank you all. Enjoy the rest of your day.
Thank you, Sarah. Thank you, Dharminder. Thank you, everyone.
Thank you
Thanks,
both.
Sarah. Thanks, everybody.
Okay.